things, yeah, or whatever, yeah. Then I jump to question number 18 first to answer our first question. Yeah. The first question. Oh, number 19. Yeah. Yeah. Anyway. All right. The first question for number 18, would you not include X1 in your comparison since? Yeah. The answer is, all right, is not include. We include, yeah. All right, so this information is known. Okay, it is known. You can use this information directly without. So here, if you want to do comparison between X1, X2, then you do not need to do that. That comparison is saved. Okay, yeah. So this condition just to save one possible comparison. Yeah, between X1 and X2. Yeah. But for other comparisons, it cannot save. For other comparisons, you still do the normal comparison. But X1 included can be used. Yeah. Not excluded. You can still use X1. For example, if you want to compare X1 and X3, you can still do it. Okay. Yeah. So only the possible saving this place. Yes. Yeah. And for this question, you need to go back to our example. Yeah. And that one, sort a 4-element array. We have that example, right? Yeah. In the hint for homework 1, you compare how close it is, how close that one to this question, how close they are. You can see the difference is here. The only difference is here. How can you fix this little gap easily? Right? You can see with this small difference, it's not very far from our final solution. Think about that. All right? Yeah. Okay, so that's for this question. Yeah. And I see a comment from question number 19. Yeah. But on my desktop, I cannot see that comment. Yeah. That's something very strange. Yeah, because from my laptop, I can see this question. Maria asked me this question. But here in my desktop, I only see Austin's question. That's something very strange. All right. So Maria asked this question, number 19, binary search, worst case. All right. Yeah. All right. Okay. Yeah. Let me explain question number 19. Yeah. All right. I just, yeah. Okay. All right. Yeah, question number 19, 5-element array, but we have this information. Yeah, X1 less than X2 and less than X3. So this subarray is ordered. It's an ordered subarray. Yeah. Then I will go to sort the whole array, but what is the remaining work? Yeah. Because we sort a subarray, or this array is partially sorted. So we need to complete the remaining work. Remaining work, basically, we just want to get the elements x1, 2, 3, x4, x5, these two elements in order. All right? Yeah. All right. Then can we do in two steps? The first step, put x4 in order. All right? Yeah. Step 2, put x5 in order. Okay? Yeah. 2 steps. Yeah. Because the current subarray is ordered, can we take advantage of this ordered information? We need to apply the structure. Okay, yeah. By the binary search. You know the binary search, right? Yeah, all right. So here, for x1, x2, x3 already sorted. Now the first step, you want to put x4 in place. By the binary search, you should compare with x2 first, right? Then there are 2 possible cases. If less than x2, x4 less than x2, then you should look at this side, right? Yeah. If greater than x2, look at this side, all right? Okay, all right. So you can get x4 in place in this way. All right. Then step number 2. All right. Here we can assume x4 has been put in place after certain number of comparisons. Yeah. Here we can assume, just one special case. Yeah. But this case is quite representative, right? Yeah. You may have a few other cases, yeah, but essentially they have the similar structure. Yeah, here I just use this one as an example, as a representative. Step 2, this time you need to put x5 in place, but here we have even number of elements, not odd, right? So when you do binary search, we can still do the binary search, right? Yeah, we compare with the median first. So this is the median, the current median. Yeah. You compare with the median first. Then you have the possible cases less than the median, greater than the median. Greater than median, you need to consider the remaining 2 elements, x3 and x4. All right? Yeah. So here, use this thinking this method. Do not apply that formula. Yeah. So Maria type our worst case formula, right? Yeah. So the formula, we have that worst case formula. Do not use that one. Do not use that one. Yeah. The worst case formula usually, when we do it, yeah, when we do it, we need to use it in the right way. Yeah. Here, I'm afraid you just plug in the number, n equals 5, you're plugging that number. That's not good. Okay? Yeah. So because I'm afraid you may use it in the wrong way. You may use it in the wrong way. Yeah. So I do not recommend you use that formula directly. Okay? Yeah. So use the steps I put here and use the binary search thinking, not formula, thinking. Yeah. The procedure that we use in the binary search. Okay? Yeah. All right, so that's this hint. Yeah. Question number 19. If it's not clear, you can ask further questions. Okay? Yeah. Now the next question. Yeah. Next question. All right, Isaac. Yes, let me read this question. We are looking for worst case in this. Yeah, we are looking for worst case. We are always looking for the worst case. Yeah. So here, let me give you the general way we solve a problem. Yeah, I mentioned this before, because only when we work on the worst case, then we can say we solve the whole problem. Otherwise, you cannot claim you solve the whole problem. If you just work on a best case or some non-worst case, then you cannot claim you solve the whole problem. But think about, if we worked on the worst case and solve it, can we claim we solve the whole problem? Yes, we can, because other cases can only be better, not worse. So we can claim we solve the problem completely. Yeah, that's the logic. All right. Then let me read your remaining questions. Yeah, look, worst case, but we need to find if x1 less than x4, and if it is, then we need to see if x2 less than x4, then we need to see x3. Isaac, are you talking about question number 19? Number 19, right? Yeah, we have 5 elements. Yeah, not 18. 18, we only have 4 elements. Yeah, all right. Yeah. Right. Yeah. But from what you write here, it looks like too much work. Okay. All right. So if, let's say, if x1 less than x4, oh yeah. First, did you follow the order of our comparison of the binary search? Yeah. So let me say in this way. All right. Because based on the hint here, yeah, here we do, because from what you type it here, it looks like you start from scratch, yeah, not following the binary search idea. All right. Here I answer your question based on the binary search idea. Okay. Yeah. All right. Yeah. First, yeah, because by the binary search we need to do comparison x2 and x4, right? Yeah, binary search. Yeah. So that means it's not your x1 and x. If you do not compare x1 and x4, that's the wrong way. Okay. So this way, you have 2 sub cases. Okay. x2 less than x4, x2 greater than x4. Okay, yeah. x2 greater than x4, then you consider, if you apply the binary search, what's the next comparison, right? You need to look at what's the next comparison. All right, yeah. And similarly, if x4 greater than x2, what should be the remaining comparisons? Things like that. Okay, yeah. Because if you follow this order, this comparison order, you can get a minimum number of comparisons. If you do not follow this order, you may use more than necessary number of comparisons. Okay? If you compare with x1, you need to use more comparisons. All right? Yeah. Okay. All right. Next, yeah. So then you just, Maria's question, want us to count or add every that could be made with the remaining. Yes, yeah. But for the worst case, all right? For the worst case, yeah. The worst case, for example, regarding x5, you should look at this side for the worst case, right? Because this side, when you do comparison with x2, you should focus on this side because you have more elements, x4 and x3 you need to consider. The left-hand side of x2, only one element. You only need one more comparison, you can put it in place. That's not a worst case. So you should, whenever you have a chance, you always look at the worst case. That's the basic idea. Okay? Always look at the worst case. When you have two different paths, choose the one that results in the worst case. And at the end, you will get a worst case solution. Okay? Yeah. All right. So next, the Robaba's question. Would you say that the worst comparison when x5 comes in is at the right? Yeah, that exactly. Yeah, exactly. Robaba's question. Yeah, yeah. In that way, you do not need to discuss the left-hand side. Yeah. Although you can, yeah, but we know, yeah, that's not the worst case. Okay, yeah. So that's not our main focus. All right, yeah. What's next? Yeah. Yeah. Good. I think you should get this one after this much discussion. You should not miss this one. Yeah. All right. Some more questions. If not, I just guess. How about that? Because I don't want to waste time. Yeah. When I do my explanation, you have time to type your new questions. All right. I see question number 17. Yeah. All right. And the number 6. Yeah. Number 17. Yeah. All right. Actually, we have a similar question in homework, right? Yeah. First, I like to go back to point out a similar question. This is our homework question. Homework question, you can look at how did we solve? Yeah, I remember. Yeah, this one. Think about question number 19. Question number 19. Similar. Yeah, similar. The pattern, the rule, slightly different. Yeah. The question: find some rule. find certain rule. Yeah, by observation. Okay, yeah, the idea. Then when we come back to our current question, yeah, discover some property. Yeah. What is the invariant? Yeah. Some quantity that never changes. Yeah. Remember in our lectures, I mentioned this invariant concept. Invariant. Yeah. Here, let me explain a little bit. That means some quantity that, yeah, some quantity that never changes for different terms. Terms. Can you find that property? Okay. Here, look at the first term. Then you look at the second term, third, and so on. Yeah. Can you find some number, some way to define a number, and this number, when you move from term to term, yeah, jump to different terms, that number never changes, keeps the same. Yeah, yeah. So that invariant, that find some invariant that helps you to keep track of all the terms. Because here, there are some ... There are many terms missing in the ... abbreviation sign, right? Yeah. So we need to keep track of them. How do we keep track of them? This invariant idea can help us keep track of all those missing terms. That's the basic idea. If you can find that, then you can use that rule. There must be some rule. If you can find that rule, you apply it, you can find the answer. Yeah, because our destination term, this is our destination term, is like that, right? Yeah. Okay, yeah. And we know its coefficient is A sub 1867 subscript. We only need to figure out the monomial part, x to the kth power, that monomial part, that k. That k, you need to find it, use the observed rule. You need to observe, discover that rule. Yeah, find it. Yeah. Using the given information, all these here, can you figure out a common rule? That's the insight. The common rule is the insight. If you can discover it, then you can solve it easily. Okay? Yeah, that's this question. Then next one, question number 6. All right. Yeah. So this one, question number 6, from its form, it is a little complicated. Yeah. It is a little complicated. Yeah. So if you work on the given forms directly, you may get overwhelmed. Okay? You may get a little overwhelmed. Yeah. So the basic idea is we need to simplify the forms. Yeah. Before we work on it. Yeah. Let's do simplification first. Yeah. What kind of simplification? Yeah. What kind of simplification? So the critical step is this. We do variable substitution. Okay? We do variable substitution. Yeah. Let x, we introduce a new variable, equals that log base 10 of n. How about that? Okay? Yeah. Log base 10 of n, this relatively complex form, we use a one single variable to replace it. Then we can simplify the 4 given options. Yeah. So now, the 4 given options, option A, just root of x. Option B, log base 10 of x. Option C, x over log base 10 of x. And option D, x squared. How about that? After you make this simplification, can you see the order of growth better in the new forms? Because it's much simpler, right? Much simpler than before, but essentially the same thing. But you can see the whole picture much better in this way. Now you do the order of growth as you did before, as you did in our homework assignment number 1. How about that? Yeah. Yeah. So use this hint this way. Okay? Yeah. X variable. Okay? Yeah. Good. Next question. Question 4. Yeah. Question 4. Yes. Yeah. Let me read the question and help you understand this question. Yeah. Now, it's a simple question. Yeah. But probably you feel you do not quite understand this question. So let me just help you understand. Yeah. Then you can solve it easily. Okay. All right. Basically, I give you the background. Yeah. Why I designed this question. Give you the background. And you can understand it. All right. Assume that the minimum number of comparisons to find the median of a 3-element array for the worst case is A, and the minimum number of the comparisons to sort a 3-element array for the worst case is B. Which of following is correct? All right. Yeah. Its background, we need to go back to the general case. General case. Yeah. So here, I'm talking about this question, all right? General case. Yeah. So one is find the median of an n-element array. That's one question, all right? Yeah. With a minimum number of comparisons. All right? Yeah. To sort an element array with B minimum number of comparisons. All right? Yeah. These two questions. Yeah. In general, which one is larger? Right? When we find the median of an array, or comparing with when we sort the whole array, which one is harder? Which one is easier? In general, finding the median is a little easier than sorting the whole array, right? Because if you sort the whole array, you can get a median immediately. But when we find the median, we do not need to sort the array. Can you see that? Yeah. So the basic fact is this. The basic fact. When we find the median, we do not have to sort the array in general. Yeah. Because our goal, we only need to identify which one is the median. We only need to get the information that is enough for the median. We do not need to get all the elements in order, right? That's too much work. That's too much work. Okay? Yeah, let me give you an idea. Yeah. Sorting, for sorting, okay? Yeah. The worst case, what do we need to do? The big O or big theta. Yeah, let me use the big theta way. Yeah. Sorting. Oh, yeah, it's too slow here. Yeah. All right. Sorting. If I use the big theta, the amount of work is big theta of n log n. Okay? Yeah. And finding the median, yeah, here I just give you the result. The amount of work we need to do is big theta of n. You can see we can do less work finding the median than sorting in general. Yeah, that's the case in general. All right. Yeah. All right. With that background, that is the background for this question number 4. Okay. With that background, now we come back to our question number 4, but it is not a general case. It's a 3-element case. It is a 3-element case. Yeah. So the general rule may not be true for the 3-element case. It's a special case, very special case. So it may not be true. Now, in this question, I ask you which of the 3 options is correct. Okay, yeah. First, you can see, yeah, because from our analysis, yeah, because if we sort the array, then we can find the median immediately without any more comparison, right? Yeah, because we need to do more work in sorting. That already tells us A less than or equal to B, right? Always. A always less than or equal to B, right? That means the option B is gone. Option B cannot be true, right? So it can be easily eliminated, option B. So you only need to consider A or C. But in A or C, which one is correct? Can you do it? Yeah. Can you solve the 3-element array for the worst case? Yeah. You need to do still, based on our previous comment, you need to do it for the worst case. Yeah. How many comparisons do you need to sort 3-element array? Because it's very simple. You just do it. And the next question, how many comparisons do you need to find the median of 3 elements? For the worst case, just do it. Okay? Yeah. It should not be too hard. Only 3 elements. Why is it so hard, right? It is quite easy for you. Yeah. After you solve these 2 simple problems, sorting 3-element array, finding the median of 3-element array, look at your answer. Yeah. Is it option A case or option C case? So that's what you need to do in question number 4. Okay? Yeah. Yeah. That's the meaning, the background, so you won't feel strange. Yeah. It's quite natural. Yeah. Something, but the special case. Special case could be different from the general case. Yeah. All right. Yeah. Next question. From other students, questions? Yeah. Any of you just ask. Yeah. Just ask. Number 5. All right. Question number 5. All right. Also simplification. Yeah. But the simplification way is slightly different from question number 6. Yeah. The basic idea still, yeah. Here, my handwriting is pretty slow. Yeah, I think, yeah. When I do the Zoom, yeah, video, yeah, at a later time, yeah, yeah, it's a little slow. Yeah. Yeah, but it's too slow. Yeah. That's something annoying. Yeah. All right. All right. Yeah. So the way we are doing here, yeah, still, yeah. Yeah, why so slow? Simplification. All right. Yeah. Ignore minor terms. ignore the minor terms. All right? Yeah. Okay. Only keep the leading terms. So for option A, yeah, option A, in the parentheses, just keep the leading term. All right? Yeah. So you simplify to log of n to the 10th. All right? Yeah. And option B, that plus 1 can be simplified. And to the 0.000, yeah, many, yeah, this many, 0, yeah. Then you compare these two simplified functions using our old way, homework way. In our homework number 1, we did a similar question, right? Yeah, we did one. And you have the answers. And we compare log function and power function. Yeah. Option B is the power function. And this is D. This is D. D number. D is a very small number, but it's positive, right? Positive. Yeah. Log function, I give you a hint for in homework number 1, use that epsilon, right? Yeah. Log, and you can use the n to the epsilon, that power function, but the epsilon is a special positive number less than any positive D number. Look at that. Use that way, connecting the dots. So we need to use that method from our homework assignment number 1. After simplification, you can apply it. This 10, log base, this n to the 10th. Do you know a property of logarithm function? Property, yeah. So that property, log x to the y, this function equals y times log of x. This property you need to know. Okay? So here our y equals 10. So you need to do that step. Bring down that number 10 to the front of the function. After that, then you can do comparison. Yeah. Because to answer this question, you need to have some basic knowledge. Here I point out those basic knowledge pieces you need to have to answer this question. If you know all these pieces, you can connect the dots to answer this question. Okay? Yeah. All right. What's the next question? Number 13. All right. Yeah. Okay. Given an unordered array with n greater than 5 elements, it is known that there are total k elements in this array that are not in place. Similar to one of our homework questions, but here I changed a little different. I modified the condition slightly here. All right. So far the same, but I added this part. K is an odd integer. We know that this is the, new condition part. Comparing with our homework. In our homework assignment, we do not have this condition. Yeah. Here, this is the modification. K, you cannot choose an even number. Yeah. The smallest possible odd number. You need to choose K here. All right? Yeah. If you go back to look at let me go back to our homework question. Yeah, look at question number 20. Yeah. Corresponding to this question number 13. Yeah. This is the corresponding one. Yeah. Refer to, yeah, that's the, of midterm. All right, yeah. Look at this answer is 2. So definitely you cannot use this answer, right? Because it is an even number. So I exclude this case. Yeah. So my new condition, odd number, excludes this 2 case. Answer 2 case. Yeah. So you need to look for a new answer with this new condition. How simple it is. Think about how simple it is. All right? Yes. So the bottom line, you cannot use our old answer. That's wrong. That's wrong. So what is the new answer? Smallest possible odd number for K, but you need to go back to look at our old homework question number 20. Yeah. So why we choose 2 there, right? Yeah. Look at that. Why we choose 2 there. Yeah. 2, that means it cannot be 1, right? We eliminate K equals 1 case. Yeah. So then the smallest number greater or equal to 1, yeah, because 1 cannot be selected by our homework question number 20, and we select 2, but here you cannot select 2, right? Here, I put a new condition, and you cannot select 2, all right? Yeah, so then you're almost there, yeah. Then you're almost there, all right? Yeah. Next question. Yeah. Yeah. Number 20. Yeah. Here, I explain the meaning, the background. Yeah. So you will answer following the right direction. Yeah. Otherwise, you may go to the wrong direction. Okay. Yeah. All right. So let's go to question number 20. Yes. This one, similar to our homework question, the last one. Yeah. That one, A array 3 elements, B array 3 elements. And here we do modification. A array 3 elements, B array 5 elements. All the number, all right? Yeah. B1, B2, B3, B4, B5, but our condition X2 greater than B3. That's the condition. Okay, yeah. Then we consider the median with, yeah, here, fourth element, smallest element of all. Okay, yeah. So the final sorted array, we have 8 elements, but our interest is at this fourth smallest, the median. Okay, yeah. Then you need to do the same thing, excluding, yeah, from the given information. What are those elements that could be eliminated from the consideration? Okay, yeah, yeah, because the median, fourth smallest, yeah, we know, yeah, yeah, here, fourth smallest, or fifth largest, right? Okay, fourth smallest means greater than 3 elements. Okay, yeah. If you can find some element that is greater than 4 elements, then it can be eliminated, right? Because the median can only be greater than exactly 3 elements. If, based on the given inequalities, you can find some element that is greater than at least 4 elements, can you eliminate it from the consideration? Yeah, all right. And here, fifth largest, that means fifth largest, yeah, that means smaller than 5 elements. All right, yeah. If you can find one element that is smaller than 6 elements, can you eliminate it? Smaller than 6, it cannot be the median, because the median can only be smaller than exactly, sorry, smaller, oh, sorry, not 5. Okay, yeah, yeah. I need to, oh, yeah, too much. Smaller than 4 elements. If you can find some element that is smaller than 5 elements, yeah, 5 elements, then it cannot be the median. Okay, yeah. So you look at from these two sides, left end and the right end, using these two conditions to do your eliminations, and try to eliminate as many as possible. Yeah. And use our last question in homework assignment number 1 to give you the idea which way you should do. All right, yeah, okay. Yeah. All right. Next question. Yeah, we do not have much time. Yeah, so probably the last question. Yeah, not too much time. Yeah, yeah. So let's see what are other questions. Yeah. All right. You can see most of these questions similar to our homework questions. So that's the reason, yeah. I do not need to, yeah. Number one, all right. So Maria, yeah, number one, yeah. All right, okay. Special set of coefficients. Yeah. Not the general, special. Yeah. Based on our experience, when we can choose special coefficients. When we can choose special coefficients, all right, then we do not need many, we can use fewer number of comparisons, right? Yeah. Here, think about, Pascal's triangle. Yeah. That you can use this structure. Okay. Yeah. Because there is no limitation you can use, right? This is one way. Another is monomial. Okay. Monomial. You can also consider. Yeah. But A5 cannot be 0, all right? Yeah. Because our polynomial, when we define a polynomial, usually we mean the leading term, the coefficient of the leading term, this one, cannot be 0. Yeah. So that's the only condition we need to keep. Yeah. Other than that, other coefficients, you can make them 0 if you like. Yeah. Yeah. But here, because the special, you have freedom to choose special coefficients to make this question as easy as possible. Yeah. All right. At the same time, yeah, for question number 2, I'd like you to connect to our homework question. Oh, not that one, this one. Homework question, we have a similar one. The first question, yeah. In this one, we let y equals to x squared. And so this one, we can let y equal to x to the 4th, all right? To simplify it. Yeah. So we can write a polynomial of y, but you need to calculate this y with some multiplications, right? Yeah. Yeah. Do not forget this part. Okay. Do not, yeah. All right. So other questions? 4 more minutes. Other questions? Yeah. Let me see. What are is the midterm still oh yeah, good question. All right. So the midterm, I plan to do this way. So first, I do not plan to extend the deadline another time. Okay. So we still keep the same deadline. But remember, I gave you the grace period before. All right. Yeah. So the same policy still give you yeah, here, right here, 1 day grace period. All right. So yeah, so that means you have another day if you need it without penalty. Okay, without penalty. Just do the best you can. Yeah, I will post this as an announcement to everyone. Yeah, so 1 day grace period. Yeah, but the deadline I do not change. I still set the midnight today as the deadline. All right. Yeah, but you have a little more room. Yeah, 1 day grace period if you need to use it. Yeah. Okay. Yeah. Two minutes to go. Yeah. All right. Will you upload? Yeah, I will. Yeah. The first thing after I complete it, the first thing I will do, process the video and upload it. So you can study. That's the reason I give you 1 day grace period, because you have more time to watch the video. Yeah. Number 9, yeah, the last possibility, number 9. Before we finish today, number 9. All right, okay. Yeah. Is it possible that we can find an algorithm with the efficiency? Yes. All right. Good question. I like you to ask this question. Yeah. All right. Go back to look at the comments. Yeah. Somewhere, look at the comments in homework assignment number 1. Yeah. Let me jump to it. Yeah. Otherwise, you may spend too much time to find the comments. Yeah. This is the homework assignment number 1 annotation, the answer. Did I do it? No, sorry. Yeah, probably I did that comments. Yeah. Oh, not homework 1. Yeah, sorry. Not homework 1. I did that comments somewhere in class. Yeah. Anyone remember? Yeah. I remember I did comments. To find the Fibonacci numbers, I talk about in a textbook, there is a solution based on the matrix multiplication. I talk about that somewhere in our class. Yeah, yeah, and in our textbook. Okay, yeah. In our textbook, and that algorithm could give us a solution, very special way to find the Fibonacci numbers. Yeah, yeah, yeah. But that should be in the recent videos. Yeah, I couldn't remember anyone. Yeah, yeah. But I can go back to look at my annotation of my notes, annotation version of the notes. Yeah, I remember I wrote on a PowerPoint slide. Okay, yeah. After I find it, I will post that page number. Which page number in which annotation file? So you can go there and look at that. That will give you the answer. That slide will give you the answer. All right? All right. So now let me stop here and do the video processing and the post. And I will also send a few announcements for the updates for this midterm. Okay? So that's all you have for the midterm. And hopefully you can do the best you can for this midterm.